Well, welcome back. We learned in the last part of our notes the difference between a concentrated solution and a dilute solution, and ways we have of actually measuring that. So we use, for example, the percent by mass or the percent by volume. Those are the most typical ways to do that. So now I want to show you some ways that scientists actually work with solutions to change their concentration. And some of these are going to make sense because you've probably done the same thing yourself. Like if you're drinking some hot chocolate and it's way too chocolatey and you say, oh, this is just too much, you need to dilute it a little bit. So think about the very simple way that you would dilute a solution of hot chocolate, because that's exactly what you're drinking there. Or what if it's been too diluted? Can you think of a way to make it more concentrated? So obviously, to dilute it, you could add some solvent, and to make it more concentrated, you could add some solute. But there's some other clever ways that I want to show you that we can accomplish similar things. So let's look at the first example here. This is the one I mentioned first. If your hot chocolate is too concentrated, you simply add some water. And when we do the measurement of concentration, and this is what I want you to write down, it'd be hard for you to draw the figure, but you could draw a little part of the diagram if you want to. But the important thing is to see that adding solvent to make X times more solution will make it X times more dilute. So for example, if you have a half of a cup of hot chocolate and you say, oh, it's way too chocolatey, if you double the amount of water, that means you double the amount of solution that you have, you will make it 2 times more dilute. Okay? If you triple the amount of solution you have by adding even more water, you will make it 3 times more dilute. Another way of saying 3 times more dilute is 1/3 as concentrated. So we can use those phrases interchangeably. So in the example that I have here, we have a volume of about 50 milliliters to start with, and we end up with about 125 after we've added some solvent. So that's about 2.5 times as much solution, which means our concentration is 2.5 times less. Okay? Or you can say it's 2.5 times more dilute. And I like that this had a little figure here, so you can kind of see what a concentrated solution looks like if the solute is there in the little red triangles versus a more dilute one. Okay, so this has about 2.5 times more solute particles that we can see compared to this in the same number of solvent particles. We can accomplish something similar, but in reverse. We could actually increase the concentration by doing the opposite. Instead of adding solvent, if the solvent is able to evaporate, we call that a volatile solvent, then however much less solution we will have that many times more concentration. So if we kind of go in reverse here and we let some of the water evaporate from our solution, if we evaporate it so our solution is 2.5 times less volume, it will be 2.5 times more concentrated. Okay, so water would evaporate, but of course water takes a long time to evaporate. Some solvents are very volatile. For example, gasoline and acetone, nail polish remover, ethyl alcohol that you get maybe for cleaning purposes. Those are very volatile, and so you can evaporate those pretty quickly. They're not the safest things to use because of that. All right, so this is really the same kind of effect in reverse as to dilution. Here's another clever way we have of doing dilution through a series of dilutions. So I've got some numbers to help us here. Try not to lose track of these. I'm going to let you, of course, have access to these notes. I don't think you'd want to draw this, but see if it kind of makes sense to you. Suppose we start on the left here with some solution of a bacteria. So biologists would do a lot of this kind of thing. If you have 50,000 bacteria per milliliter, which is a different way of measuring concentration, maybe we need a more dilute solution. And so if we take 1 milliliter and put it in a new empty test tube, and then we add 9 milliliters of water. So you see what we're doing here. We're taking some of the original solution, 1 milliliter of it, then we add 9 milliliters of water. You see what you've essentially done is you've taken 1 milliliter and you've turned it into 10. So you have 10 times as much solution. Well, that's that dilution effect. If you have 10 times as much solution, you'll have a 10 times more dilute solution, or 10 times less concentrated. So we call that a 1 to 10 dilution. So instead of 50,000 bacteria in each milliliter, we would only have 5,000 bacteria per milliliter. Now we could take that dilution, that 1 to 10 dilution, and then take 1 milliliter of it into an empty test tube, add 9 milliliters of water, and now we're 10 times more dilute than the one before, which makes it a 1/100 dilution of the original. Okay, so we've done two 10 times dilutions that makes a 1 to 100 dilution. So instead of 50,000, now we only have 500 bacteria in each milliliter. And so they show two more 1 to 10 dilutions. And every time you do that, you get 1/10 of the concentration that you had before. So after, as you can see here, 4 dilutions, we're now 10,000 times more dilute. We're down to 5 bacteria instead of the 50,000. Here's another similar example. I thought this one might be a little easier to follow. This is a 1 to 2 dilution because we're taking 5 milliliters of the solution and then we're adding 5 more milliliters of water. So we take our 5 and we turn it into 10. So we have twice as much solution after we've diluted it, and that makes 1/2 of the dilution. So if we do that once, we get a 1 to 2. If we do it again, we get 1 to 4. If we do it a third time, we get 1 to 8. So now, again, we just look at the original. This particular sample started with 100,000. Now we've got 8 times less than that in each milliliter, so 12,500. And we could keep doing halves and halves and halves, and we just get a more and more dilute solution. Thought I'd show you what this looked like, and I have a solution here that'd be kind of easy to see. So let's take a look at that. So I'm going to do a series of 1 to 2 dilutions, and so this is the solution I'm using. It's just blue food coloring and water, and I'm going to rough it out. I'm not going to measure this real carefully, but I also have some just empty water here that I'm going to use. So I'm going to take, that was probably about 1/4 of a cup, maybe 10, 15 milliliters or so. And I'm going to add the same amount of just plain water. Okay. And can you see the difference there in the color? The fact that this is a kind of a more dull color and this is a deeper allows you to see that that's a little more dilute. And then if I take this, so this is a 50% or a 1 to 2 dilution. And if I put a little in here, again, I'll put about 10 milliliters in there. And I'll add another 10 milliliters of water. So I just made it half as concentrated or twice as dilute. So again, we can see the original. And then here's a 1 to 2 dilution. And here's a 1 to 4 solution. Scientists might also call this a 50% dilution, and this one a 25%, because it's got 25% of the concentration as the original does. So this is something, again, you have experience with if you've just been eating and drinking things and had to do that sort of thing. So if you need to go back and maybe write down what some of those processes are, I'm going to give you a chance to practice this a little bit and see if you can figure out some of these. I'm going to keep the numbers real simple, so these are maybe proportions you can do in your head, things like halves and doubles and 3 times and 1/3. I'm not going to do weird numbers or anything like that. Okay? Hope this was helpful.